So now we're going to move on to the other stages of cellular respiration as if oxygen is present. So the next one that's going to happen is pyruvate oxidation. And if you remember, the end product of glycolysis was pyruvate. So what's going to happen is pyruvate is just going to get converted into two things, carbon dioxide and acetyl-CoA. So carbon dioxide, that is the reason that we breathe out carbon dioxide when we exhale. Acetyl-CoA is going to go into the next stage that we're going to talk about. So what's going to happen is pyruvate is going to get some electrons harvested. So NAD plus is getting reduced to NADH. Now notice I say for each molecule of pyruvate that gets converted, one NAD plus gets reduced to NADH. Now, if we remember what happened in glycolysis, if we go back to here, when we look at this, you can see that we started out with glucose and we ended up with two pyruvates, one up here and one down here. Pyruvic acid, same thing. So if we're talking about the next stage, which is pyruvate oxidation, that means two NAD pluses are getting reduced to NADH because it's happening for this and then it's happening for this. So if I go through here, here is our mitochondrion right here. Here's the membrane. And we've got pyruvate, our end product of glycolysis, going in. And what's going to happen is one of the byproducts is CO2, and the other one is NADH. Now, this is only one molecule of pyruvate. So if you imagine this happening twice, that means we would have two carbon dioxides and two NADHs. Okay. This next one kind of shows it right up here. So here's our pyruvate. There's that NAD plus getting reduced to NADH, and there's our carbon dioxide that's getting created, and then acetyl-CoA is the end product. Now, were there any ATPs in anything I just talked about? No. So if we go back to the notes, you notice that there are no ATPs created in pyruvate oxidation. Very important. It's the only stage where no ATPs are created. Now the next part is going to be what's called the Krebs cycle or the citric acid cycle. Now back to our little drawing here, you can see in this cycle what's going to happen is acetyl-CoA is going to go into it, and what's important is more carbon dioxide is going to be created, and now we've got a whole bunch of electrons that are getting harvested and taken to that next stage. So 3 NAD pluses are getting reduced to NADH. Another thing that's happening is ATP is being created. Over here, FAD is getting reduced to FADH. That's very similar to NAD, so more electrons. Now, how many ATPs have we created? Well, you can see there's one right here, but remember, there were two pyruvates. So this whole cycle is happening twice. So that means 2 total ATPs are being created, a whole bunch of carbon dioxide, and a real huge amount of electrons are being harvested. So let's go back to the notes and take a look at what we've got written here. So, beginning of that cycle, acetyl-CoA, which remember is the result of pyruvate oxidation, is going in, and 2 more ATP molecules are going to get created. They're going to happen through that substrate level phosphorylation, so just like that first stage we talked about. And several electrons are getting removed by the reduction of NAD plus to NADH. Okay, now we're going to go on to stage 4. Stage 4 is a little bit more involved, so I'm going to stop here, and then the next video will start up right at this point.